Hello friends, this video on P block element part 26 is brought to you by examfear.com. No more fear from exam. Property we'll discuss is the metallic character. So if you see here in this group 16, my oxygen, sulfur, these are my non-metals. In fact, selenium also they called as non-metal. And my tellurium is metalloid and polonium is metallic. So you see this polonium is metallic, tellurium is metalloid, and the first three are non-metal. In fact, for selenium there is a debate actually. Some books classify selenium as metalloid also. Okay, so if you go down the group, what is happening is the metallic character is increasing. These were non-metal, then metalloid, and then we got metal. Okay. The next is the catenation. So this catenation tendency is primarily shown by sulfur. Oxygen, very few only to some extent. Sulfur, large extent. Large extent of catenation. And after these again they don't show much. For sulfur, if you see, they have something like this, H, S and H. That means there will be so many sulfur attached, sulfanes they call, or they have something like this, HO3S, S, like there's too many S and then SO3. Something, this is also SO3. There is so many compound sulfur forms which has huge sulfur, like that is catenation, nothing but the characteristic of an element to form links with the same element. For example, carbon has a huge catenation property, that is the best in all the elements. Sulfur also shows some catenation property. Oxygen, very less. To talk about the oxidation state, the electronic configuration is Ns2 and P4, right? So it either has to lose 6 electrons to become stable or gain 2 electrons to be stable. Only two options it has, right? To gain the extra stability, it has to lose 6 electron or gain 2 electron. But losing 6 electron is not feasible. And with this, looks like the oxidation state should vary from -2 to +6 because it loses 6 electron or gain 2 electron. So theoretically, that should be the oxidation state. That is theoretically. But there is a big but here. Losing 6 electron is not a joke. Right? Because no atom will feel like losing 6 electrons, because it changes a lot of things. It's very difficult to lose 6 electron, 1 electron, again 2 electron, the size is less, and the 4th and the 5th electron, the 6th electron, it's very difficult to lose 6 electrons. Right? Also, if you somehow form a metal with or element with +6 oxidation state, the stability of this will be very less. It won't be stable. So the +6 is something which is not seen, right? So it typically shows -2 to +4. In fact, I won't say it is impossible. +6 also exists but rare. For example, SO3 is one example where it is in +6 state. Little rare. So due to inert pair effect, the tendency to form +4 is more than +6. Two reasons. One is due to inert pair effect. Tendency to form +4 is more than +6 as we go down the group. And the second reason is that losing 6 electron is difficult. For example, if you see oxygen, losing 6 electron is very impossible. Why? Because oxygen size is small, it can't lose 6 electrons, so it doesn't show +6 oxidation state. But if you talk about sulfur, it does show +6 oxidation state. My selenium also shows +6 oxidation state. My tellurium also shows +6 oxidation state. But as you go down the group, my polonium is not showing +6 oxidation state, only +4 maximum because of inert pair effect. Inert pair effect, because of this it is showing only at the max +1, right? So +6 is possible, but very difficult, because it is very difficult energetically to get rid of 6 electrons. Okay, so if we talk about oxygen now, as I have shown, oxygen shows -2, -1. It also shows 0 oxidation state, +1 and +2. Example I can give you for 0, it is my pure oxygen. For -2, a good example is water. In water, oxygen has -2 oxidation state. -1 is peroxide, that is also a very famous example. +1 is again little rare, that is O2F2. And +2 is all the more rare, that is OF2. So this is only one molecule actually which shows +2 oxidation state, OF2. So this OF2 is my oxygen difluoride, O2F2 is oxygen dioxygen difluoride, and H2O2 you know is hydrogen peroxide, H2O is water, and O2 is nothing but oxygen molecule. That is for oxygen. For sulfur also -2, I can give example of H2S. In H2S we have -2. If we talk about the +2, I can give example of SCl2. SCl2. If we talk about the +4 oxidation state, a very good example is SO2. If we talk about +6 oxidation state, a very good example is SO3. Same thing with my selenium, tellurium and polonium. Okay. For oxygen, there is no oxidation state beyond +2. Please note. Why? There are so many reasons. If oxygen lose more than 2 electron, it becomes unstable. There is no d orbital to form bond, and this is a large energy required actually to lose a electron beyond that. You see the oxygen, the electronic configuration is 1s2, 2s2, 2p4. So in this large energy required, if you want to remove this 6 electron, because in the second orbital tightly held by this nucleus, right? So apart from oxygen, other elements actually shows -2, +2, +4, +6. Why? And these higher oxidation states are possible down the group. Why? Because of the empty d orbital also, right? So tendency to show, again if you see -2 also decrease down the group as the size increase. So tendency to show -2 also decrease down the group, and tendency to show +6 also decrease down the group. So in this case, my both -2 and +6 are not there. +6 is not there, -2 is not there for polonium. So hope you understood the oxidation states concept. So technically it should have -2 to +6, and it does show. Oxygen doesn't show because the size is very small. For oxygen, +2, no oxidation state beyond +2 is possible for oxygen. No empty d orbital, and size is very small, and taking out these electrons because the second shell is very difficult. So oxygen shows only +2 oxidation state at the max. Other elements, sulfur, selenium, tellurium, they shows +6 also. Polonium also doesn't show +6, but it shows still +4. Why? Because of the inert pair effect. Okay. Let's talk about some of the physical properties trends. So if you see again here, my oxygen, sulfur, these are non-metals. If you talk about the selenium and tellurium, again there's a debate on selenium, so I'll put selenium as metalloid. We talk about polonium, it's a metal. So from non-metal to metal. For this polonium, it's a radioactive element and the half-life is very less. The half-life is only 13.8 days only for polonium. And all these elements, they exhibit allotropy. For sulfur, there are almost 20 allotropes. For oxygen, there are almost 9 allotropes. There are so many allotropes for all these elements. So if we talk about the physical property, oxygen is the only one which is gas at standard temperature and pressure. All these are my solid in standard temperature and pressure. We'll talk about why it is like this. My oxygen is gas, other are solid. One is because of the covalency also. Oxygen generally forms O2. These forms S8. Sulfur forms S8. So we'll talk about that. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.